Hi guys, today I'm going to go over the CIE IGCSE Extended Paper 2 to February-March 26 for chemistry. So starting with question 1, a sample of helium gas is placed in a free-moving gas syringe. The temperature of the helium is increased and the pressure of the helium does not change. Which statement is correct? So for these kind of questions you can use the combined gas law equation, which would be P1 V1 over T1 equals P2 V2 over T2. So since they've said the pressure doesn't change, we can assume that it's constant in this case. So these two cancelled out, and you're left with V1 over T1 equals V2 over T2. So what I'm going to do then is I'm just going to plug in some values. So if you're increasing the temperature, we need to see what effect this has on the volume. So let's say my volume initially is 20 centimeters cubed divided by 20 degrees Celsius. This is equals to V2, which we're not going to calculate. And then since we're increasing temperature, let's say to 40. So then it's going to be V2 equals 20 over 20 times 40, so 40. So in this case, volume increases. So your answer is going to be C or D. And normally if volume increases, this means your helium atoms will be further apart. So your answer is D. Question 2, so it says an experiment is set up as shown. Cotton wool soaked in concentrated hydrochloric acid on one side of this tube and cotton wool soaked in concentrated ammonia. So it says the hydrochloric acid gives off hydrogen gas, which dissolves in water to form an acid, and the concentrated ammonia gives us ammonia gas, which dissolves to form an alkali. So they're asking about the color of the universal indicator and which row describes and explains the first change in the universal indicator paper. So normally in these questions, this is talking about the rate of diffusion for the specific gases. So for this, remember, diffusion is affected by the size and the mass of particles. So the smaller, lighter ones will diffuse faster. So in this case, we need to calculate the MR of the hydrochloric acid. So MR of HCl will be 1 plus 35.5, so 36.5. And MR of ammonia, NH3, will be 14 plus 3 times 1, so 17. So in this case, ammonia will be the fastest diffusing gas, so your universal indicator will change to blue, and the answer would be then ammonia moves more quickly, so A. Question 3 then, we've got X2 plus is an ion of a group 2 element. What is the highest value of the ion? So the first option is the nucleon number. Remember, the nucleon number is the total number of neutrons and protons in the nucleus of an atom. So due to this then, the answer would be A, because that is the biggest number for every single element. It's a combination of the neutrons and protons. Question 4, it says the position of two elements P and Q in the periodic table are shown. P and Q react together to form a compound. So first of all, Q is in group 1, so it forms +1 ion, and P is in group 7, so it will form a -1 ion. So they've told you you're going to form a compound Q and P. Remember, this is a metal and non-metal, so this is going to be an ionic compound, so your charges must add up to 0. So in this case, the formula is just QP. Question 5 then, which row describes the properties of simple molecular compounds? So simple molecular compounds are your simple covalent compounds. So first of all, they are poor conductors of electricity, so your answer is between B and C. And simple covalent compounds have low melting and boiling point values, so your answer is C. Next, how are the structures of diamond and silicon 4 oxide similar? So you should remember, in diamond you've got carbon atoms arranged in a tetrahedral manner, so each carbon bonds to 4 other carbons. And in silicon 4 oxide you've got silicon, surrounded by 4 oxygens. And this is a giant network. So they're both giant covalent structures. So A says molecules of both diamond and silicon 4 oxide are held together by weak attractive forces. That is wrong. It's actually just a giant network of covalent bonds. They both contain atoms arranged in planes held together by weak bonds. Well, they are not arranged in planes. That would be for graphite. They both contain ions. That's wrong because there's not ionic bonding. These are both giant covalent structures. So your answer is D. Yes, they each have 4 covalent bonds. Next question then. We've got solid X and solid Y are both pure substances that contain ions. So when you're looking at substances that contain ions, you've got ionic compounds and you've got metals. So ionic compounds, remember you have positive and negative ions. And metals, you've got positive ions and a sea of delocalized electrons. So in this case, then it says X is not an electrical conductor. So one thing we need to make sure we fully read is that both of these are solid. So remember, if you have a solid that is not an electrical conductor and it contains ion, this is probably your ionic compound, because ionic compounds do not conduct electricity when solid. They only conduct electricity when molten or in solution, because the ions can move carrying a charge. And then Y, it says, is an electrical conductor, so Y must be your metal. So using this then, X is a compound, Y is an element. Yep. Second one, the ions in X are held in a lattice. The ions in Y are not held in a lattice. This is wrong because both of these consist of a lattice structure. So ionic compounds consist of alternating positive and negatively charged ion arranged in a regular pattern, so a lattice, giant ionic lattice. And in metallic structures, you've got a positively charged ions arranged in a regular lattice with a sea of delocalized electrons. And then finally, X contains both positive and negative ions, and Y contains only positive but no negative ions. This is correct. So your answer is 1 and 3, so C. Next, a sample of magnesium is burned in air. A student calculates that 10 grams of magnesium oxide should be produced. After the reaction, the student determines the percentage yield of magnesium oxide. Which formula is used to determine the percentage yield of magnesium oxide? So you need to remember this formula. Percentage yield is the actual mass obtained divided by the theoretical mass that you calculate. So theoretical calculated mass times 100. So using this then, your answer is C. Question 9. So question 9 is a moles calculation. So you've got 4.55 grams of zinc is reacted with 50 centimeters cubed of 2.25 mole per decimeter cubed hydrochloric acid. The equation is shown. Which volume of hydrogen gas at room temperature and pressure is produced in this reaction? So first of all, whenever you're given data for 2 of the reactants, you probably have to calculate which reactant is limiting and which one is in excess. So first of all, let's display all the data. So we have to calculate the volume of hydrogen, and we are given that we've got 4.55 grams of zinc, and we've got 50 centimeters cubed of 2.25 moles per decimeters cubed of hydrochloric acid. So first of all then, let's calculate the number of moles of zinc. This will be mass divided by area because it's a solid. So this will be 4.55 divided by the AR of zinc from the periodic table, which is 65. So this gives you 0.07 moles. Next, number of moles of hydrochloric acid. So hydrochloric acid, this would be concentration times by volume. So it comes from rearranging this formula. So in this case, 2.25 times by the volume And remember, volume has to be in decimeters cubed, so 50 over 1,000. So using this then, the number of moles is 0.1125 moles. So now we've got the number of moles of both the zinc and the hydrochloric acid. And the ratio, the stoichiometric ratio, is 1 to 2. So we've just calculated you've got 0.07 moles of zinc and 0.1125 moles of hydrochloric acid. So to identify which reactant is limiting or excess, what I normally do is I cover the information given by one of my reactants. So in this case, let's imagine they never told us the number of moles of hydrochloric acid. And so we were only given the zinc moles. So using this then, so if we have 0.07 moles of zinc, this means using the 1 to 2 ratio, I would have 0.07 times by 2, which gives you 0.14 moles of hydrochloric acid it should be reacting with. But in reality, we have less. We've got 0.1125 moles. So this means that my hydrochloric acid is limiting and the zinc is in excess. So whenever a reactant is in excess, you can ignore the number of moles for that, because that's not going to help you calculate the number of moles of your product. So using this then, we can calculate the number of moles of hydrogen. So hydrochloric acid to hydrogen. We've got a 2 to 1 ratio in the equation. So if we've got 0.1125 moles of hydrogen, to go from hydrochloric acid to hydrogen, it's going to be number of moles of hydrogen will be 0.1125 over 2. So 0.05625 moles. And then finally, since we're calculating the number of moles of gas at room temperature and pressure, we can use the formula number of moles equals volume divided by 24. So volume of hydrogen will be number of moles times 24. So using this then, it's 0.05625 times by 24. So your answer will be 1.35 decimeters cubed. So your answer is A. Next. So we've got a question about electrolysis. So in the electrolysis diagram, oxidation is occurring at electrode 1 and reduction at electrode 2. So one thing I remember here is red cat. So this means reduction occurs at the cathode. So this is one way of remembering this. So since they're telling you reduction occurs at electrode 2, electrode 2 must be your cathode, and electrode 1 the anode. So using this then, cathode is negatively charged electrode and anode is the positively charged electrode. I remember either add for anode, or you can remember panic. So positive anode, negative is cathode. And so remember then, electrons always go from the negative side of the battery to the positive, because they are negatively charged, so they'll repel that. So movement of electrons is occurring like this. And so let's see what the question wants. Which row shows the direction of movement of electrons in the external circuit of the positive and the positive ions in the electrolyte? So direction of movement of the electrons in the external circuit, we've just figured that out. So electrons go from the negative to the positive side. So you're going from electrode 1 to electrode 2. So your answer is either A or B. And then the movement of the positive ions in the electrolyte. So normally the positive ions are your cations. Cations go to the cathode. Cations are the positive ones. And anions normally go to your anode. So in this case, your positive ions are going to go towards the cathode. So they're going to go from electrode 1 to electrode 2. So your answer is A. Next. Which row describes an advantage of using the hydrogen-oxygen fuel cell and an advantage of using petrol engine? So hydrogen-oxygen fuel cell, remember, is only going to produce water as your product. So it says can travel a greater distance after the fuel tank has been filled. That's wrong, because technically hydrogen is a gas. So you're going to be filling up your tank with less gas compared to how much ever liquid would fit in it. There are more petrol filling stations than hydrogen filling station. Well, that's not really an advantage for the hydrogen-oxygen fuel cell. This does not produce carbon dioxide gas, which causes global warming. That's correct. No risk of fire or explosion. That is incorrect, because hydrogen is an explosive gas. So based on this, we've just eliminated all of these, and your answer C. Question 12 then. Which statement describes activation energy? So remember, activation energy is the minimum energy colliding particles must possess in order to react. So using this then, A is incorrect, B is incorrect, your answer C. Next, hydrogen peroxide decomposes to form water and oxygen. So the reaction is exothermic. And what is the enthalpy change for this reaction? So first of all, they've told us that the reaction is exothermic. Exothermic reactions have a negative enthalpy change. So automatically you know your answer can't be any of these. And then using our bond energy values, we can calculate the enthalpy change. So I'm quickly just going to draw this molecule over here. So they've drawn hydrogen peroxide for us as your reactant. You've got 2 molecules of hydrogen peroxide forming 2 molecules of water and 1 molecule of oxygen. So I normally like to separate out this reaction into bond breaking and bond making. So you break bonds in your reactants and you make bonds when you form products. So using this then, breaking and making, we are breaking the oxygen to oxygen single bond in hydrogen peroxide, and since there's 2 molecules, there'll be 2 times O to O single bond, which will be broken, and then you've got O to H bonds over here. Each molecule has 2, and you've got 2 molecules, so 4 times O to H bond. Then we're forming O to H bonds in water. Each one, there's 2 times 2, so 4 times O to H, and 1 O2O double bond. So both sides you're breaking and making the same number of OH bonds, so this is cancelling out. So you've got then 2 times O2O single bond, so 2 times 150, which is 300, and 1 times O2O, so double bond, so that's 1 times 496, and this gives you 496 then. So to calculate enthalpy change, it's always bond breaking, take away bond making. So this is 300, take away 496, which gives you minus 196 kilojoules per mole. So your answer's B. Next, which row shows the sources of nitrogen and hydrogen in the Haber process? So nitrogen is 78% of air, so it has to be either C or D. And then you can actually get hydrogen from methane. So your answer is D. So you need to know the sources of nitrogen and hydrogen for the Haber process. Question 15, which statement about anhydrous salts is correct? So remember, you have 2 anhydrous salts you need to know about. So you have anhydrous cobalt chloride. These are both tests for water, and you have anhydrous copper sulfate. So you go from blue to pink with cobalt chloride and white to blue with copper sulfate. These are both tests for water. So these are reversible reactions as well. So the first one says anhydrous cobalt chloride turns from white to blue when added to water. That's wrong. Anhydrous cobalt chloride loses water on gentle heating. No, because anhydrous already means there's no water molecules of crystallization here. Anhydrous copper 2 sulfate reacts with water to make hydrated copper sulfate. Yes, that is correct. And the last one, anhydrous copper sulfate turns from blue to white. That's wrong. It's white to blue when water is added. Next question. So this is the equation represents the reaction of iron 2 sulfate with acidified aqueous potassium manganate 7. Which ion is reduced and which one is the reducing agent? So first of all, let's calculate all the oxidation numbers. So manganese here is +7. Then iron, it's an iron, so it's +2. Here it's +2 and +3. So in general, what has happened is manganese has gone from +7 to +2. So that's going down in oxidation numbers, so that's a reduction. And iron has gone from +2 to +3, so that's going up in oxidation numbers, so that's oxidation. So the ion that is reduced would be the manganese. And the reducing agent, remember, is a species that is itself oxidized, but carries out the reduction of another species. So in this case, the species that is oxidized would be iron 2+. So your answer is C. Next question, which statement about hydrochloric acid is correct? So hydrochloric acid is a strong acid. So first of all, it says it is completely dissociated in aqueous solution. Well, yes, the definition of a strong acid is a proton donor that fully dissociates into its ions in aqueous solution. It turns thymolphthalein blue. That is incorrect. Actually, acids are colorless with thymolphthalein. It would be with an alkali that it's blue. It acts as a strong acid in aqueous solution. Yep. Produces hydroxide ions? No. It produces hydrogen ions or protons. So the answer is 1 and 3, so A. Next, sulfuric acid dissociates in water in 2 stages. So you've got H2SO4 forms H plus and HSO4 minus ions, and HSO4 minus ions forms hydrogen ions with SO4 2 minus. So one key thing to bear in mind here is that these equations are reversible. So which statements about these equations are correct? HSO4 can donate and accept protons. So we've got HSO4 here. It is accepting a proton in this equation and going that way. And in this equation down here, it is also donating protons. So yes, this is correct. H2SO4 is a proton donor. Well, yes, it's formed a proton. Dissociated to form a proton, yeah? And then SO4 2 minus is the only base. So remember, in this case, a base is a proton acceptor. And this statement would be incorrect because you have HSO4 minus also acting as a proton acceptor when this reaction is going this way. So this is wrong. So your answer is 1 and 2, so A. Next question. Which statement about amphoteric oxides is correct? Remember, amphoteric oxides are oxides that can act as acids and alkalis or bases. So in this case, you've got they react with acid but not with base. That's incorrect. They react with acids and bases to form a salt and water. That is correct. So your answer is B. Next, which property of elements increases across a period in the periodic table? Metallic character? No, because you're going from metal to non-metallic character. Number of electron shells? No, it's electrons added to the same shell across a period. Number of outer shell electrons? That is correct, because you're adding one extra electron as you move across a period each time to the same shell. So the answer is C. 21. Which two compounds react together to form the insoluble salt lead 2 chloride? So remember, to form an insoluble salt, you need 2 soluble salts. So in this case, let's look at the options. 1 and 3 it says, so option 1 and 3, lead 2 nitrate and silver chloride. Well, one of this is insoluble, so nope. Next, 1 and 4. So you've got lead 2 nitrate is soluble and sodium chloride is soluble. And then this will form lead chloride and sodium nitrate. So yes, 2 soluble salts forming an insoluble salt. Which statement describes properties of transition elements? They form white compounds only. That is incorrect. Most of them form colored compounds. They are ductile. Well, that is a property of all metals. They have high densities. Yes. They form positive ions by gaining electrons. Well, that is incorrect because you form positive ions by losing electrons. So your answer is 2 and 3, so C. Next, which statement explains why aluminium has good resistance to corrosion? So you need to remember aluminium is special. So if you have a block of aluminium, you will have a protective outer oxide layer. So in this case, aluminium is highly reactive. Nope. Aluminium has an oxide layer on its surface. Yes. Next, coating iron helps prevent rusting. Which coating will continue to protect the iron even when the coating is damaged? So you've got, first of all, copper. Well, copper is a metal that is less reactive than iron, so it will not prevent it from rusting. Paint and plastic only provide thin layer of temporary protection, so nope, can't be those two. And finally, zinc would be your answer. Normally, iron is galvanized or coated with other metals such as zinc, which is more reactive than iron, and it is oxidized normally preferentially than iron. So even if there are gaps and scratches and the iron is exposed, the zinc is more reactive, therefore loses electrons and forms ions in preference to iron metal. So your answer is D. Next, which statements about the substances in water from natural sources are correct? So in this case, detergents contain nitrates that cause diseases. Well, detergents are not usually present in natural sources. Then it says sewage contains harmful microbes that cause disease. So yes, that is correct. Next, we have all metal compounds are toxic. Well, that is incorrect because not all metal compounds are toxic. Normally, metal compounds containing heavy metals are normally toxic. And then it says fertilizers contain nitrates and phosphates which damage aquatic life. Well, that is correct because this leads to eutrophication. So your answer is D. Next question. You've got the diagram represents processes X and Y and their effect Z in increasing global warming. So you need to bear in mind this is talking about the greenhouse effect. So you've got the sun, greenhouse gases in the atmosphere, and the earth. So sun normally emits thermal energy. Then your earth normally emits thermal energy back to the atmosphere, but not all of it goes back up. So what we have is some of it is then absorbed by the greenhouse gases, and these then re-emit some of it back to earth and some of it back. So in this case then what we have is there's less thermal energy lost to space, which is the overall effect of this process Z. So your answer has to be between A and B. And X and Y are two processes that occur consecutively, and as a result of these, you've got less energy emitted back to space. So you have absorption of thermal energy by greenhouse gases is correct. So your answer would be A. And the emission of thermal energy to Earth. Next, which equation describes the formation of two atmospheric pollutants that are not present in clean air? So first of all, carbon dioxide is present in clean air. So these three equations would be incorrect because they have carbon dioxide in them. So your answer is D. It contains carbon monoxide and carbon, which are atmospheric pollutants not present in clean air. Next question. Some of the fractions obtained from the fractional distillation of petroleum are used as fuels for vehicles. Which two fractions are used as fuels for vehicles? So first of all, A and B would be incorrect because bitumen is used to make roads. It's a thick viscous liquid normally near the last fraction. Then we have gasoline, yep, that is a fuel for vehicles, and kerosene, yes, that's a fuel for jets. So your answer is C. Next question, 29. The displayed formula of butanoic acid is shown. Butanoic acid reacts with ethanol to form an ester. What is the structural formula and the empirical formula of this ester? So this carboxylic acid reacts with ethanol. So this is ethanol. When a ester is formed, you lose the OH from a carboxylic acid and the H from the alcohol. So this is going to form this carboxylic acid and alcohol compound. So that's the carboxylic acid bit, the O, and this is the ester group. So using this then, this is your ester bond. So the structural formula over here, the COO bit, is where the carboxylic acid group came from. So this is going to be C3H7CO. So your answer is either A or B. And then it's asking you for the empirical formula of the ester. Remember, this is the simplest whole number ratio. So if we count quickly the number of carbon, hydrogen and oxygen in our ester, this is C6H12O2. This is divisible by 2. So your empirical formula is C3H6O. So your answer is B. What is the structural formula of propan-1-ol? So structural formula would mean it's going to be B. So propan-1-ol, the OH is on carbon number 1, if you label it like that. And this, remember, would be molecular formula, general formula. So your answer is B. Alkenes can undergo addition reactions with aqueous bromine, hydrogen, or steam. Which reactions of ethene need a catalyst? So remember, addition reactions is when you're adding across the double bond. So aqueous reaction with bromine, that occurs normally at room temperature, so it doesn't need a catalyst. Steam, reaction with steam requires H3PO4 catalyst. Normally this forms then an alcohol. And reaction with hydrogen normally forms an alkane. This reacts and needs nickel catalyst. So it's 2 and 3, so your answer is D. Next question, which conditions are used for the manufacture of ethanol by fermentation? So this requires the catalyst yeast, so it's either A or D. And yeast is a biological catalyst. So in this case, it would denature at very harsh conditions. So the answer is D. Which statement about an aqueous solution of ethanoic acid is correct? So ethanoic acid, remember, is a weak acid. So it says it reacts with magnesium to form water as its product. So magnesium is a metal. Metals plus acid make salt and hydrogen, not water. It reacts with sodium carbonate to form carbon dioxide. So this is correct. Sodium carbonate is a metal carbonate, which is a type of base. Acid plus metal carbonates makes a salt, water, and carbon dioxide. So your answer is B. Next, which statement explains why plastics should be recycled? Most do not decompose when they are added to landfill. That is correct. They are normally non-biodegradable. They pollute rivers and the ocean where they harm wildlife. Yep. And they can produce toxic gases when they are burnt. Yes. So your answer would be A. Which statements about the plastic PET are correct? So remember, another name for PET would be terylene. And this is a type of synthetic polyester, man-made synthetic polyester. So polyesters are a type of condensation polymer. It is not a polyamide, and it can be converted into monomers and repolymerized easily. Yes, they undergo hydrolysis and condensation reactions. So your answer is 1 and 3, so C. Next, the diagram represents part of the structure of a protein. 3 atoms have been labeled X, Y, and Z. Which elements are X, Y, and Z? So for proteins, you need to remember you've got the amide, functional group, which looks like this. So using this then, X must be O, Z must be the N, and Y must be a H. So it's either this or this, and so your answer is C. Locating agents are often used in paper chromatography. Which mixture requires a locating agent? So locating agents are normally sprayed on chromatograms when the spots are not visible, so they are colorless. So your answer is A, a mixture of two colorless substances. Next, a blue solid Q is soluble in water. Which method is used to obtain pure solid Q from an aqueous solution? So this means it dissolves in water. Chromatography, no. Crystallization, yes. Normally it's to form crystals from a solution. Filtration wouldn't work and neutralization wouldn't. So your answer is B. Next, two test tubes each contain a sample of water. One test tube contains pure water, but the other one contains water with dissolved sodium chloride as an impurity. Which tests may be used to identify the test tube that contains pure water? So first of all, remember, pure substances have a sharp, definite melting and boiling point value. And if you add an impurity, this means that melting point decreases and boiling point increases generally. So the first one is measure the boiling point of each water sample. Yes, that could identify this because the pure water should boil at 100 degrees, whereas the impure sample will boil at a temperature above 100 degrees. Then test each sample with acidified aqueous silver nitrate. Well, silver nitrate is a test for halide. And our impurity is sodium chloride. So this will give a white PPT, white precipitate with the sodium chloride, and no precipitate or no visible reaction with the pure water. So yep. Test each sample with anhydrous copper sulfate. Well, anhydrous copper sulfate is a test for water. Both of your samples contain water, so it will give you positive for both. So your answer is 1 and 2, therefore A. And lastly, the results of some tests on dilute aqueous solution X are shown. So these are normally the qualitative analysis tests given in the paper 6. So it says which cation is present in X. So your tests are ammonia dropwise and in excess, sodium hydroxide dropwise and in excess. So the fact that you've got white PPT rules out C because chromium is a transition metal. Transition metals normally give colored precipitates. And then it says in ammonia your precipitate's soluble in excess, and in sodium hydroxide it's also soluble in excess. So I have some tricks to remember this then. So the remaining 3 cations all give white PPT. And then I remember that zinc, the Z is like a funny looking S. So this one is soluble in excess in both ammonia and sodium hydroxide. Then calcium, white PPT, and calcium is in your bones. Bones don't dissolve, so insoluble in excess. And then aluminium is the odd one out, where with sodium hydroxide it's soluble, and with ammonia it's insoluble. So based on this then, your answer will be D, zinc 2+. Thank you very much for listening, and I hope this video was helpful.